Hello, welcome to this video. So this video will be about a conventional question in paper 1 of DSE about application of trigonometry in three-dimensional problems. So in the figure we have a tetrahedron. Okay, so that would be a four-faced polyhedron. So let P be a point line on AD, okay, such that BP is perpendicular to AD. Okay, BP is perpendicular to AD. So that will be in this way. And then AC equals CD. AC equals AD equals CD equals 13. Oh, that means equilateral. Okay, so 13. And then BC is XCM. Oh, okay. And then BD is 12. Okay, BD is 12. It's 12. ABD. Oh, this angle 72. Okay, in part A1, we want angle BAD. Okay, angle BAD. Oh, we have 13. Oh, that's pretty obvious because we want this angle and then corresponding to 12, and then this is 13, and then we have this 72. Okay, so that's why. So I should label this as yellow angle then. Okay. This is 72. Okay, so and then we want this corresponding to 12. So that's easy. So sine angle BAD over 12 equals sine 72 over 13. And then BAD will be approximately equals to, here we use the calculator. So 61.4 degrees. So remember this is A maybe. So A2 CP we need this. Okay, CP. Okay, where should we find it? So after we have 61.4, this is 61.4. So we can find BP then. So what's the point then? BP. Okay, so maybe at the buffer. So the way will be like this. Okay, first of all we can find out the right angle, and then we can solve for AB. We can solve AB, and then after that we can solve AP. Okay, and then I think the key step would be using the equilateral triangle, a hidden equilateral triangle, by considering this triangle. So that would be ACP, and then we want CP. So yeah, we want CP, and then corresponding to 60 degrees. And then if AC is also find AC is yellow. So AC is 13, So that means, okay, if we find AP, oh, this is truly important. So if we find AP, then we can find out CP as well. Okay, so that's why for A2, so first of all we find AP, and then AP, and then finally CP. The flow will be like this. Okay, so first of all for AB, okay, for AB here, so that would be using the cosine formula maybe, or maybe you can use the sine formula as well. Yeah, maybe we can use the sine formula. So AB over sine degrees minus 72 minus 61.4. Good. And directly approximate to approximate equal to 13 over sine 72. And then we need to make use of the resulting part A. So that would be 9.93. Good. And then we consider this right angle triangle, because we have 61.4, and then this is B, this is P, and this is A. This is right angle, and then we can find AP. So AB is 9.93. So that's why here AP will be direct proportional, will be approximately equals to 9.93 times cosine of 61.4 degrees. Okay, this one may be saved to B. No need. Directly use cosine 61. Okay, A. So that will be 4.76. And then after that 4.76, so that will be here. And then at last, okay, so this one we may need to save it as B then. Good. And then after that, so this, you can use the cosine formula. 13 squared plus 4.76 squared minus 2 times 13 times 4.76, and then times cosine 60. Good. So that will be 11.4 cm. Okay, this one I will probably save it to C then. Good. Okay, so that will be part A2. Okay, so here comes the last part. So here the correspondence claims that angle BPC. So angle BPC. So this angle. So this angle would be right. This angle would be the angle. Will be the angle between the face angle between the face NBD and the face ACD. Now you can see angle ACD is equilateral, as I mentioned before, and then angle ABD. Okay, so that would be this face, and then you can see after highlighting, so you can see the line of intersection is here. And then along the line of intersection, it seems that the question shows, okay, the representative point P here, and then already this is a normal. BP is a normal. Okay, so already angle APB equals 90. Okay, so what's left here? So here, if the angle BPC is the angle we want or we required, that means this angle has to be 90 degrees as well. So that's why, okay, we want to know whether angle DPC or angle CPA equals 90 degrees or not. So that's why, erase that. So ACP. Now AC we know that is 13, right? So is this a 90? Is this a 90? Okay, so luckily AP we saved. This is 4.76, and then CP has been found as 11.4. So we just try to make use of the converse of Pythagoras theorem to check. So part B, so we try to check AC squared. That be 13 squared equals 169. While AP squared plus PC squared would be approximately equals to 152. And then since AC squared is not equal to AP squared plus PC squared, so angle APC is not 90. So that's why you can see the required angle would not be check it here, more space. So the required angle is not angle BPC. So that's why the claim is disagreed on. Okay, and that's all for this problem. Thank you for watching.